Picture this, a classroom floating 250 miles above Earth, where students in sleek, zero-gravity suits conduct experiments that would be impossible on the ground. The teacher, a holographic projection, explains the intricacies of astrophysics while the Milky Way glows through the panoramic windows. This isn't science fiction, it's the future of education. Welcome to a world where space-based learning and research are not just possibilities but realities reshaping how we think, teach, and explore. In this video, we're diving into 25 groundbreaking predictions about the future of space-based education and research. From zero-gravity classrooms to interstellar universities, these ideas will redefine what it means to learn and discover. By the end of this journey, you'll see how the cosmos could become the ultimate classroom, unlocking creativity, innovation, and collaboration on a scale we've never imagined. So buckle up, because the future of education is about to take off and it's heading straight for the stars. Now, let's take a closer look at our first prediction: zero-gravity classrooms. Imagine stepping into a learning environment where the rules of gravity no longer apply. In these floating classrooms, students wouldn't just sit at desks, they'd move freely, experimenting and interacting with their surroundings in ways that are impossible on Earth. This unique setting has the potential to completely transform how we teach and learn. For instance, in a zero-gravity environment, complex scientific concepts like fluid dynamics or orbital mechanics become tangible. Students could observe how liquids behave without gravity pulling them down or experiment with objects in motion, gaining a deeper understanding of physics firsthand. But it's not just about science. Zero-gravity classrooms could also spark creativity and innovation. Without the constraints of gravity, students might approach problems from entirely new angles, literally and figuratively. Picture a group of students designing a structure that must function in microgravity, forcing them to think outside the box and collaborate in ways they never have before. This kind of hands-on, immersive learning could sharpen problem-solving skills and inspire a new generation of thinkers and creators. And this isn't just a futuristic dream. Experiments in microgravity are already happening. For example, astronauts aboard the International Space Station have conducted experiments on everything from crystal growth to plant development, providing valuable insights that could shape future curricula. These real-world examples show us that zero-gravity classrooms aren't just possible, they're already in the works, paving the way for a new era of education that's as limitless as space itself. As we move forward, the idea of zero-gravity classrooms opens up endless possibilities for how we teach, learn, and innovate, but this is just the beginning. Next, we'll explore how space-based education could take STEM programs to new heights, offering students unparalleled opportunities to engage with cutting-edge technologies and experiments. Now, shifting our focus to the next frontier in space-based education, let's dive into the exciting potential of space-based STEM programs. Picture this: students not just learning about science, technology, engineering, and mathematics, but actually applying these disciplines in the most extraordinary laboratory imaginable, space itself. In this environment, STEM education would transcend textbooks and traditional classrooms, offering students the chance to work with cutting-edge technologies and conduct experiments that push the boundaries of human knowledge. Imagine a group of students designing and launching their own small satellites, or programming robots to perform tasks in microgravity. These hands-on experiences would allow them to see the direct impact of their work, fostering a deeper understanding of complex concepts. For instance, students could study how materials behave in the vacuum of space, or explore the challenges of growing plants in zero-gravity environments, topics that are not only fascinating but also critical for the future of space exploration and colonization. Space-based STEM programs would also provide students with access to advanced tools and technologies that are typically reserved for professional researchers. Think about the possibilities, using high-powered telescopes to observe distant galaxies or analyzing data from experiments conducted on the International Space Station. These opportunities would not only inspire students but also prepare them for careers in fields like aerospace engineering, astrophysics, and biotechnology. Moreover, space-based STEM education could foster a sense of global collaboration. Students from different countries could work together on international projects, sharing ideas and resources to solve real-world challenges. This kind of teamwork would mirror the collaborative nature of space exploration itself, where nations unite to achieve common goals. It's not just about learning STEM, it's about using these disciplines to build a better future for humanity. As we look ahead, the integration of STEM programs into space-based education promises to ignite curiosity, drive innovation, and equip students with the skills they need to tackle the challenges of tomorrow. But this is just one piece of the puzzle. Next, we'll explore how virtual reality could revolutionize space-based learning, bringing the cosmos to classrooms on Earth in ways we've never seen before. Now, let's take a leap into the future of immersive learning with virtual reality space labs. Imagine stepping into a classroom where the walls dissolve, and suddenly, you're floating in the vast expanse of space, surrounded by stars, planets, and the infinite wonders of the cosmos. This is the promise of virtual reality in space-based education, a tool that could transform how students learn, explore, and interact with the universe, all from the comfort of Earth. Virtual reality technology has already begun to revolutionize education, but its potential in space-based learning is truly groundbreaking. With VR, students could conduct experiments in simulated zero-gravity environments, manipulate virtual models of spacecraft, or even walk on the surface of Mars, all without leaving their classrooms. These immersive experiences would allow students to engage with complex concepts in a way that feels tangible and real, making abstract ideas easier to grasp and far more exciting. For example, a biology class could use VR to study the effects of microgravity on plant growth, observing how roots and stems behave differently in space compared to Earth. A physics lesson might involve students launching virtual rockets, adjusting variables like thrust and trajectory to see how they affect the mission's success. These hands-on activities would not only deepen understanding but also spark curiosity and creativity, encouraging students to think like scientists and engineers. One of the most exciting aspects of VR space labs is their accessibility. While not every student may have the opportunity to travel to space, virtual reality can bring space to them. Schools in remote or underserved areas could use VR headsets to give their students the same high-quality, immersive experiences as those in more resource-rich environments. This democratization of space-based education could inspire a new generation of explorers, regardless of their background or location. Moreover, VR could facilitate collaboration on a global scale. Students from different parts of the world could meet in a shared virtual space, working together on experiments or exploring celestial phenomena as a team. This kind of international cooperation would mirror the collaborative spirit of space exploration itself, fostering a sense of unity and shared purpose among young learners. As we look to the future, the integration of virtual reality into space-based education holds immense potential. It's not just about learning facts and figures, it's about experiencing the wonders of the universe firsthand, igniting a passion for discovery that could last a lifetime. And as we continue to push the boundaries of what's possible, the next frontier we'll explore is the rise of international space universities, where students from around the globe come together to learn, innovate, and shape the future of humanity. Now let's shift our gaze to an even more ambitious vision, the rise of international space universities. Picture this, a state-of-the-art campus orbiting Earth, where students and researchers from every corner of the globe come together to learn, innovate, and push the boundaries of human knowledge. This isn't just a dream, it's a future that could redefine education as we know it. International space universities would serve as hubs of global collaboration, breaking down the barriers of geography and culture. Imagine a classroom where a student from Japan works alongside peers from Brazil, Kenya, and Canada, all united by a shared passion for space exploration. These institutions would not only provide cutting-edge education, but also foster a sense of global citizenship, encouraging students to think beyond borders and work together to solve humanity's greatest challenges. One of the most exciting aspects of these universities is their potential to combine diverse perspectives. Space exploration has always been a collaborative effort, with countries pooling resources and expertise to achieve common goals. By bringing students and researchers from different nations together in a single space-based institution, we could accelerate innovation and discovery. For instance, a team of engineers from India might collaborate with biologists from Germany to design sustainable life support systems for long-term space missions, while sociologists from Mexico and astronomers from Australia study the cultural and scientific implications of living in space. These universities would also offer unique opportunities for cultural exchange. Living and learning in space would require students to adapt to new environments and ways of thinking, fostering empathy and understanding. Shared experiences like watching Earthrise from a space station window or conducting experiments in microgravity would create bonds that transcend nationality, language, and tradition. This cultural melting pot could inspire new ideas and approaches, enriching both education and research. Of course, the establishment of international space universities would come with its own set of challenges. Issues like funding, accessibility, and equitable representation would need to be addressed to ensure that these institutions benefit all of humanity, not just a privileged few. But the potential rewards are immense. By creating spaces where the brightest minds from around the world can come together, we could unlock new possibilities for education, research, and global cooperation. As we look ahead, the idea of international space universities represents more than just a new way to learn. It's a bold step toward a future where humanity works together to explore the cosmos. And as we continue to dream big, the next frontier we'll explore is the concept of dedicated space-based research stations for students, where young minds can contribute to groundbreaking discoveries that shape the future of space exploration. Now, let's take a closer look at an idea that could revolutionize how students engage with science and research: dedicated space-based research stations designed specifically for young minds. Imagine a facility orbiting Earth, equipped with state-of-the-art laboratories and tools, where students from around the world can conduct experiments, analyze data, and contribute to groundbreaking discoveries. This isn't just a far-off dream. It's a vision that could transform education and inspire the next generation of scientists, engineers, and explorers. These research stations would offer students unparalleled opportunities to work in microgravity environments, conducting experiments that simply aren't possible on Earth. Picture a team of high school students designing and testing a new type of plant growth system for space agriculture, or college students analyzing the effects of microgravity on cellular behavior. These hands-on experiences would not only deepen their understanding of scientific principles, but also ignite a passion for discovery that could shape their future careers. One of the most exciting aspects of these stations is their potential to democratize access to space research. By creating dedicated facilities for students, we could ensure that young people from diverse backgrounds have the chance to participate in cutting-edge science. This could level the playing field, giving students from underfunded schools or developing nations the same opportunities as those from more privileged institutions. Imagine a student from a rural community contributing to a global research project on renewable energy in space, or a young researcher from a small town helping to develop new materials for space habitats. The possibilities are endless. These stations would also foster collaboration on an unprecedented scale. Students from different countries and disciplines could work together on shared projects, combining their unique perspectives and skills to tackle complex challenges. For example, a team of biology students from South Africa might collaborate with engineering students from Sweden to design a sustainable water filtration system for use in space. This kind of interdisciplinary teamwork would not only accelerate innovation, but also teach students the value of cooperation and global problem solving. Of course, building and maintaining these research stations would come with its own set of challenges. Issues like funding, safety, and accessibility would need to be carefully addressed to ensure that these facilities are both effective and inclusive. But the potential benefits far outweigh the obstacles. By giving students the chance to conduct real-world research in space, we could inspire a new generation of thinkers and doers who are equipped to tackle the challenges of the future. As we look to the stars, the idea of space-based research stations for students represents more than just a new way to learn. It's a bold step toward a future where education and exploration go hand in hand. And as we continue to push the boundaries of what's possible, the next frontier we'll explore is the role of artificial intelligence in space-based education, where cutting-edge technology meets the limitless potential of young minds. Now, let's shift our focus to a groundbreaking innovation that could redefine how students learn in space: artificial intelligence-powered tutors. Imagine a future where every student aboard a space station or lunar base has access to a personalized AI tutor, tailored to their unique learning style, pace, and interests. These AI tutors wouldn't just deliver lectures or quizzes. They'd act as mentors, guiding students through complex concepts, offering real-time feedback, and adapting lessons to ensure mastery of the material. One of the most exciting aspects of AI tutors is their ability to provide individualized attention, something that's often challenging in traditional classrooms. For instance, a student struggling with astrophysics could receive step-by-step explanations and interactive simulations, while another excelling in the subject might be challenged with advanced problems or research opportunities. This level of customization ensures that no student is left behind and everyone has the chance to reach their full potential. But the benefits of AI tutors go beyond academics. In the isolated and high-pressure environment of space, these systems could also play a crucial role in supporting students' mental and emotional well-being. By analyzing speech patterns, facial expressions, and even physiological data, AI tutors could detect signs of stress or frustration and offer encouragement, relaxation techniques, or even suggest a break. This holistic approach to education would help students stay focused, motivated, and mentally healthy, which is especially important in the demanding context of space. Another key advantage is the ability of AI tutors to facilitate real-time collaboration among students, even across vast distances. Picture a group of students from different space stations working together on a project, with their AI tutors coordinating tasks, providing resources, and mediating discussions. This kind of seamless teamwork would not only enhance learning outcomes, but also prepare students for the collaborative nature of future space missions and research endeavors. Of course, integrating AI tutors into space-based education isn't without its challenges. Ensuring the reliability and security of these systems in the harsh conditions of space would be a top priority. Additionally, there's the question of how to balance AI-driven learning with human interaction, as the role of teachers and mentors remains vital in fostering creativity and critical thinking. Striking this balance will be key to creating an educational environment that's both innovative and nurturing. As we look ahead, the potential of AI-powered tutors in space-based education is immense. By combining cutting-edge technology with the timeless principles of teaching and learning, we could create a system that's not only more effective but also more inclusive and inspiring. And as we continue to explore the possibilities of space-based education, The next frontier we'll delve into is the fascinating intersection of space tourism and learning, where adventure meets education in the most extraordinary way. Now, let's turn our attention to a field that's as practical as it is fascinating: space agriculture studies. Picture this: students aboard a space station, not just learning about biology and botany, but actually growing their own food in microgravity. This isn't just a futuristic dream, it's a necessity as we look toward long-term space exploration and colonization. Space agriculture studies would equip students with the skills to tackle one of humanity's most pressing challenges in space: how to sustainably produce food in an environment where resources are limited and every drop of water counts. Imagine a curriculum where students experiment with hydroponics, aeroponics, and other soil-less farming techniques, learning how to optimize plant growth in confined spaces. They'd explore how to balance light, nutrients, and carbon dioxide levels to create the perfect conditions for crops like lettuce, tomatoes, and even wheat. These hands-on experiences wouldn't just teach them about plant biology, they'd also instill a deep understanding of resource management and sustainability skills that are crucial not just in space, but here on Earth as well. One of the most exciting aspects of space agriculture studies is the opportunity for students to solve real-world problems. For instance, how do you grow food when there's no natural sunlight? Students might work on designing and testing artificial lighting systems that mimic the sun's spectrum. Or how do you recycle water efficiently in a closed-loop system? These are the kinds of challenges that would push students to think creatively and apply their knowledge in innovative ways. But space agriculture isn't just about growing food. It's also about understanding the broader implications of sustaining life in space. Students would study the psychological and social benefits of tending to plants in an otherwise sterile environment. Research has shown that caring for plants can reduce stress and improve mental well-being, which is especially important for astronauts and space settlers who face the isolation and monotony of life far from Earth. By integrating these insights into the curriculum, space agriculture studies would offer a holistic approach to education that nurtures both the mind and the spirit. Of course, there are challenges to overcome. Space is a harsh environment with radiation, temperature fluctuations, and limited resources posing significant obstacles to agriculture. Students would need to learn how to engineer resilient systems that can withstand these conditions while maximizing efficiency. This would require a blend of biology, engineering, and environmental science, making space agriculture studies a truly interdisciplinary field. As we look to the future, the inclusion of space agriculture in educational programs could have far-reaching implications. Not only would it prepare the next generation of space explorers and settlers, but it could also inspire new solutions to Earth's own agricultural challenges. By teaching students how to grow food in the most extreme conditions imaginable, we're equipping them with the tools to create a more sustainable future both in space and on our home planet. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the thrilling intersection of space tourism and learning, where adventure and education collide in the most extraordinary ways. Now, let's shift our gaze to a realm where adventure meets education: space tourism, and its potential to revolutionize learning. Imagine students not just reading about space in textbooks, but actually boarding spacecraft for short-term educational trips. This isn't science fiction, it's a future where the boundaries of the classroom extend far beyond Earth's atmosphere. Space tourism could offer students the chance to experience microgravity, witness the curvature of our planet, and conduct experiments in orbit, all while gaining a first-hand understanding of the challenges and wonders of space exploration. Picture this: a group of high school or university students embarking on a week-long journey to a space station. During their stay, they could participate in experiments designed specifically for educational purposes, such as observing how plants grow in microgravity or testing the effects of space on simple chemical reactions. These experiences wouldn't just be thrilling, they'd be deeply educational, providing students with insights that no Earth-based classroom could replicate. The opportunity to see Earth from space could also foster a profound appreciation for our planet's fragility and the importance of environmental stewardship. But space tourism's role in education wouldn't stop at scientific experiments. It could also inspire a new generation of thinkers and innovators. Imagine the impact of a young student returning from a space trip with a renewed passion for engineering, astronomy, or environmental science. The awe-inspiring experience of seeing the cosmos up close could ignite curiosity and ambition, driving students to pursue careers in fields that push the boundaries of human knowledge and capability. This kind of experiential learning could be a game-changer, transforming how we think about education and its potential to shape the future. Of course, integrating space tourism into education comes with its own set of challenges. Accessibility and cost are significant barriers, at least in the early stages. However, as space travel becomes more affordable and widespread, we could see partnerships between educational institutions and space tourism companies offering scholarships or subsidized trips for students. Virtual reality and live streaming technologies could also play a role, allowing students who can't physically travel to space to participate in these experiences remotely. This hybrid approach could democratize access to space-based education, ensuring that more students can benefit from these extraordinary opportunities. The intersection of space tourism and education also opens up exciting possibilities for interdisciplinary learning. Students could explore not just the science of space, but also its cultural, historical, and philosophical dimensions. For instance, a trip to space could include lessons on the history of space exploration, the ethics of space colonization, or even the artistic inspiration drawn from the cosmos. This holistic approach would enrich students' understanding of space as more than just a scientific frontier. It's a canvas for human imagination and ambition. As we look ahead, the fusion of space tourism and education could redefine what it means to learn. It's not just about acquiring knowledge, it's about experiencing the world and the universe in ways that inspire, challenge, and transform. And as we continue to explore the possibilities of space-based education, the next frontier we'll delve into is the creative potential of space-based art and creativity programs, where the cosmos becomes a muse for new forms of expression. Now, let's turn our attention to a dimension of space-based education that transcends science and technology, the realm of art and creativity. Imagine a future where the vastness of space becomes a canvas for human expression, inspiring students to create in ways that are as boundless as the cosmos itself. Space-based art and creativity programs could open up entirely new avenues for self-expression, blending the wonders of the universe with the limitless potential of the human imagination. Picture this: a student floating in a zero-gravity environment, brush in hand, painting strokes that defy Earth's gravity. Or perhaps a musician composing a symphony inspired by the eerie silence of space, where sound behaves in ways we've never experienced before. These programs wouldn't just be about creating art, they'd be about redefining what art can be. The unique conditions of space microgravity, the absence of atmosphere, and the sheer scale of the cosmos could inspire entirely new forms of artistic expression, from visual arts to music, dance, and even performance art. But the impact of space-based art programs goes beyond the creation of new works. They could also serve as a powerful tool for emotional and psychological well-being. Living and working in space can be isolating, and art offers a way to process and express complex emotions. For students, engaging in creative activities could provide a sense of connection and purpose, helping them navigate the challenges of life in space. Art could become a universal language, bridging cultural and linguistic divides among international crews and fostering a sense of unity and collaboration. Moreover, space-based art programs could inspire a deeper appreciation for the beauty and fragility of our planet. Imagine a student creating a sculpture that captures the delicate balance of Earth's ecosystems, or a photographer capturing the breathtaking view of our planet from orbit. These artistic endeavors could serve as a reminder of the importance of environmental stewardship, encouraging students to think critically about their role in preserving our home. The integration of art and creativity into space-based education also opens up exciting possibilities for interdisciplinary learning. Students could explore the intersection of art and science, using creative techniques to visualize complex scientific concepts or designing innovative solutions to space-related challenges. For instance, a student might use 3D modeling to design a habitat for Mars, blending artistic vision with engineering principles. This fusion of disciplines could spark new ideas and innovations, pushing the boundaries of both art and science. As we look to the future, space-based art and creativity programs could redefine how we think about education and human expression. They remind us that the cosmos is not just a place for exploration and discovery, it's also a source of inspiration, a muse for the creative spirit. And as we continue to explore the possibilities of space-based education, the next frontier we'll delve into is the fascinating world of space-based medical research, where the mysteries of the human body meet the challenges of life beyond Earth. Now, let's shift our focus to a field that holds immense potential for both education and humanity's future in space: space-based medical research. Imagine a classroom not on Earth, but orbiting high above, where students are not just learning about the human body, but actively studying how it adapts to the unique challenges of space. This is where the mysteries of microgravity meet the cutting edge of medical science, opening doors to discoveries that could transform healthcare both in space and on Earth. In a space-based medical research program, students could explore how the human body responds to the absence of gravity. For instance, they might study the effects of microgravity on bone density, muscle atrophy, and cardiovascular health. These are not just theoretical concepts, they're real challenges faced by astronauts, and understanding them could lead to breakthroughs in treating conditions like osteoporosis or heart disease back on Earth. Students could analyze data from experiments conducted in space, gaining first-hand experience in interpreting results and developing solutions, but the possibilities don't stop there. Space-based medical research could also delve into the development of new treatments and technologies. Imagine students working on innovative drug delivery systems designed to function in microgravity, or experimenting with 3D bioprinting to create tissues and organs in space. These advancements could revolutionize medicine, offering new ways to address health challenges both in space and on Earth. For example, the unique conditions of space might allow for the creation of more precise and effective medications, or even the growth of organs for transplantation. Another fascinating area of study could be the psychological and neurological effects of long-term space travel. Students might explore how isolation, confinement, and the absence of natural light impact mental health, and develop strategies to support astronauts on extended missions. This research could have profound implications for understanding and treating mental health conditions on Earth, offering new insights into the human mind. Space-based medical research programs could also foster collaboration between students, scientists, and medical professionals from around the world. By working together on shared challenges, they could accelerate the pace of discovery and innovation. This collaborative approach could lead to the development of new medical technologies, treatments, and protocols that benefit everyone, regardless of where they live. As we look to the future, space-based medical research represents a powerful intersection of education, science, and human well-being. It's not just about preparing for life in space, it's about improving life on Earth. And as we continue to explore the possibilities of space-based education, the next frontier we'll explore is the critical role of environmental studies in understanding and protecting our planet from the vantage point of space. Now, let's turn our attention to a field that could redefine how we understand and protect our planet: space-based environmental studies. Picture this: students and researchers stationed in orbit, equipped with advanced tools to observe Earth from a perspective that was once unimaginable. From this vantage point, they could study our planet's ecosystems, monitor climate change, and explore strategies for planetary conservation. This isn't just about looking down at Earth, it's about gaining insights that could help us safeguard our home for generations to come. One of the most exciting aspects of space-based environmental studies is the ability to observe Earth in real time. Students could analyze data from satellites and space stations, tracking changes in weather patterns, deforestation, and ocean health. This hands-on experience would allow them to see the big picture, understanding how interconnected systems like the atmosphere, oceans, and landmasses influence one another. For example, they might study how melting polar ice caps affect global sea levels or how wildfires impact air quality across continents. These observations could lead to more accurate climate models and better informed policies to combat environmental challenges. Another key area of focus could be planetary conservation. Space-based programs could explore how to protect not just Earth but other celestial bodies as well. Students might investigate the environmental impact of space exploration, such as the effects of rocket launches on Earth's atmosphere or the potential for mining asteroids without harming their ecosystems. This research could pave the way for sustainable practices in space, ensuring that our exploration of the cosmos doesn't come at the expense of the environments we encounter. Space-based environmental studies could also inspire innovative solutions to Earth's most pressing problems. Imagine students developing technologies to clean up space debris or designing systems to harness solar energy more efficiently. These advancements could have far-reaching implications, not just for space exploration but for addressing energy and waste management challenges on Earth. For instance, the same technologies used to recycle resources in space could be adapted to reduce pollution and conserve resources on our planet. Collaboration would be at the heart of these programs, bringing together students, scientists, and policymakers from around the world. By working together, they could share knowledge, pool resources, and develop global strategies to address environmental issues. This spirit of cooperation could extend beyond Earth, fostering a sense of shared responsibility for the health of our planet and the broader universe. As we look ahead, space-based environmental studies represent a powerful opportunity to deepen our understanding of Earth and beyond. It's about equipping the next generation with the tools and knowledge they need to tackle environmental challenges from a truly global perspective. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the fascinating world of language and communication studies in space. Now, let's shift our focus to a fascinating aspect of space-based education that goes beyond science and technology: language and communication studies. Imagine a classroom orbiting Earth where students from dozens of countries come together to learn not just about the cosmos, but also about each other. In this multicultural, multilingual environment, effective communication becomes more than just a skill, it's a necessity. Space-based language programs could teach students how to navigate linguistic and cultural differences, fostering collaboration and understanding in ways that are critical for the future of space exploration. One of the most exciting possibilities is the development of universal communication strategies. In space, where crews often include members from different nations, the ability to communicate clearly and respectfully is essential. Students could learn not only multiple languages but also the nuances of cross-cultural communication. For example, they might study how to convey complex scientific ideas across language barriers or how to resolve misunderstandings in high-pressure situations. These skills wouldn't just be useful in space, they could also enhance global cooperation back on Earth. Another key area of focus could be the study of how language evolves in space. Over time, as space habitats become more permanent, new dialects or even entirely new languages could emerge. Students might explore how isolation, limited social interaction, and the unique challenges of space life influence the way people communicate. This research could provide insights into the nature of language itself, shedding light on how humans adapt their communication in extreme environments. Space-based language programs could also incorporate cutting-edge technology to enhance learning. Imagine using artificial intelligence-powered translation tools to facilitate real-time conversations between students who speak different languages. Or consider the potential of virtual reality to create immersive language learning experiences, where students practice speaking in simulated space environments. These tools could make language acquisition faster, more engaging, and more practical for future space missions. Beyond practical communication skills, space-based language studies could also explore the role of storytelling and cultural exchange. Students might share folktales, poetry, or personal stories from their home countries, creating a rich tapestry of shared human experience. This cultural exchange could help build a sense of unity and mutual respect among spacefarers, reminding them that despite their differences, they are all part of the same journey. As we look to the future, space-based language and communication studies could play a vital role in preparing the next generation for life beyond Earth. By teaching students how to connect across cultures and languages, these programs could help create a more inclusive and collaborative space community. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the intriguing world of space-based history and archaeology. Now let's journey into the past as we explore the fascinating realm of space-based history and archaeology. Picture this: students aboard a space station, not just studying the stars but uncovering the stories they hold. Space-based history and archaeology programs could offer a unique perspective on the universe, blending the study of ancient celestial phenomena with the rich history of human space exploration. One of the most intriguing possibilities is the exploration of ancient celestial events. Imagine students analyzing the remnants of supernova, studying the formation of galaxies, or even investigating the origins of our solar system. These programs could provide hands-on experience with cutting-edge tools and technologies, allowing students to piece together the cosmic history that shaped the universe we know today. By examining these ancient phenomena, students could gain a deeper understanding of how the universe evolved and how Earth fits into the grand tapestry of space. But space-based history isn't just about the cosmos, it's also about humanity's journey into the stars. Students could delve into the history of space exploration, from the early days of rocketry to the monumental achievements of the Apollo missions and beyond. They might study the challenges and triumphs of past space missions, learning valuable lessons about innovation, perseverance, and collaboration. This historical perspective could inspire the next generation of explorers, showing them how far we've come and how much further we can go. Another exciting aspect of space-based archaeology is the potential to uncover artifacts from humanity's early ventures into space. Imagine students sifting through the remains of old satellites, space probes, or even lunar landers, piecing together the story of our first steps beyond Earth. These artifacts could serve as tangible reminders of our progress, offering insights into the technology, culture, and ambitions of the space age. By studying these relics, students could connect with the pioneers who paved the way for today's space exploration. Space-based history and archaeology programs could also explore the cultural and societal impacts of space exploration. Students might examine how space missions have influenced art, literature, and global perspectives, or how they've shaped international relations and scientific collaboration. This interdisciplinary approach could highlight the profound ways in which space exploration has transformed our world, both scientifically and culturally. As we look to the future, space-based history and archaeology could play a vital role in preserving humanity's legacy in the stars. By teaching students to explore and document our cosmic past, these programs could ensure that the stories of our achievements and discoveries are not forgotten. And as we continue to push the boundaries of space-based education, the next frontier we'll explore is the exciting world of space-based entrepreneurship. Now let's shift our focus to a bold and exciting frontier, space-based entrepreneurship. As humanity expands its presence beyond Earth, the opportunities for innovation and business in space are growing at an unprecedented rate. Imagine a future where students in space-based education programs are not just learning about science and technology, but also how to build and manage businesses that thrive in the unique environment of space. Space-based entrepreneurship programs could teach students how to identify opportunities in the space economy, from developing new technologies to creating services that support life and work in space. For example, students might learn how to design and market products tailored to the needs of space travelers, such as advanced life support systems, space-friendly clothing, or even entertainment options for long-duration missions. These programs could also explore the logistics of running a business in microgravity, addressing challenges like supply chain management, resource allocation, and communication across vast distances. One of the most exciting aspects of space-based entrepreneurship is the potential for innovation. Students could be encouraged to think outside the box, developing solutions to problems that don't even exist on Earth. Imagine a student team creating a new type of solar panel optimized for space conditions, or inventing a way to recycle waste materials into usable resources on a space station. These programs could foster a culture of creativity and problem-solving, equipping students with the skills they need to succeed in the rapidly evolving space economy. Another key focus of space-based entrepreneurship could be collaboration. As space exploration becomes more global, businesses in space will need to work across borders and cultures. Students might learn how to navigate international partnerships, negotiate contracts, and build networks that span the globe or even multiple planets. This emphasis on collaboration could prepare students to lead the way in creating a thriving, interconnected space economy. Of course, space-based entrepreneurship also comes with its own set of challenges. Students would need to understand the legal and ethical considerations of doing business in space, from property rights to environmental impact. They might explore questions like, who owns the resources mined from an asteroid? How do we ensure that space businesses operate sustainably? These discussions could help students develop a well-rounded perspective on the responsibilities that come with innovation in space. As we look to the future, space-based entrepreneurship programs could play a crucial role in shaping the next generation of space pioneers. By teaching students how to innovate, collaborate, and lead in the space economy, these programs could help unlock the full potential of humanity's expansion into the cosmos. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the fascinating world of space-based psychology and mental health studies. Now, let's turn our attention to a critical yet often overlooked aspect of space exploration, the human mind. As we venture further into the cosmos, understanding the psychological and mental health challenges of living and working in space becomes essential. Space-based psychology and mental health studies could play a pivotal role in preparing future generations for the unique demands of life beyond Earth. Living in space presents a range of mental health challenges that are vastly different from those on Earth. Isolation, confinement, and the absence of familiar environments can take a toll on even the most resilient individuals. Space-based psychology programs could focus on teaching students how to cope with these challenges, equipping them with tools to maintain mental well-being in extreme conditions. For instance, students might learn about the importance of routines, mindfulness practices, and virtual social interactions to combat feelings of loneliness and stress. Another key area of study could be the psychological effects of microgravity. Research has shown that prolonged exposure to microgravity can impact cognitive function, mood, and even sleep patterns. Space-based psychology programs could explore these effects in depth, helping students understand how to mitigate them. Imagine a curriculum that includes hands-on experiments where students analyze how microgravity influences decision-making or emotional regulation, providing valuable insights for future space missions. Collaboration with mental health professionals on Earth could also be a cornerstone of these programs. Students might engage in virtual therapy sessions or participate in research projects that examine the long-term psychological impacts of space travel. By combining space-based education with cutting-edge mental health practices, these programs could pave the way for innovative solutions to support astronauts and space settlers. One fascinating aspect of space-based psychology is the potential for cultural and interpersonal dynamics. As space missions become more international, understanding how different cultures interact in confined environments will be crucial. Students could study cross-cultural communication, conflict resolution, and team dynamics, preparing them to work effectively in diverse teams. This knowledge could be invaluable not only for space missions, but also for fostering global collaboration on Earth. Ethical considerations would also play a significant role in space-based psychology programs. Students might explore questions like, how do we ensure equitable access to mental health resources in space? What are the ethical implications of using technology to monitor or influence mental states? These discussions could help students develop a nuanced understanding of the responsibilities that come with caring for mental health in space. As we look to the future, space-based psychology and mental health studies could become a cornerstone of space education. By addressing the psychological challenges of space exploration, these programs could ensure that humanity is not only physically prepared but also mentally resilient as we reach for the stars. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the integration of robotics and engineering in space-based learning environments. Now, shifting our focus to the mechanical marvels that will shape the future of space exploration, let's explore the integration of robotics and engineering in space-based education. As humanity ventures further into the cosmos, the need for advanced robotics and engineering expertise becomes increasingly critical. Space-based robotics and engineering programs could equip students with the skills to design, build, and maintain the technologies that will drive exploration and habitation beyond Earth. Imagine a classroom where students are not just learning about robotics, but actually building and programming robots designed for space environments. These robots could perform tasks like repairing satellites, constructing habitats, or even assisting astronauts during missions. Space-based engineering programs could offer hands-on experiences, allowing students to test their creations in microgravity or simulate the harsh conditions of space. This practical approach would prepare students for real-world challenges, fostering innovation and problem-solving skills that are essential for the future of space technology. One exciting area of study could be autonomous robotics. Students might learn how to program robots to operate independently in space, where communication delays with Earth make real-time control difficult. These autonomous systems could be used for tasks like mining asteroids, exploring distant planets, or maintaining space stations. By mastering these skills, students would be at the forefront of developing technologies that could revolutionize space exploration. Another key focus could be the design of sustainable engineering solutions for space. Students might explore how to create energy-efficient systems, recycle resources, or develop materials that can withstand extreme temperatures and radiation. These innovations would not only support long-term space missions but also have applications on Earth, contributing to sustainability efforts in industries like renewable energy and construction. Collaboration with space agencies and private companies could also play a significant role in these programs. Students might work on real-world projects, such as designing components for spacecraft or developing prototypes for new technologies. This collaboration would provide invaluable experience and help bridge the gap between education and industry, ensuring that graduates are ready to contribute to the growing space economy. Ethical considerations would also be an important part of space-based robotics and engineering education. Students might discuss questions like, how do we ensure the responsible use of autonomous systems in space? What are the implications of using robots to perform tasks traditionally done by humans? These discussions would encourage students to think critically about the impact of their work and the responsibilities that come with advancing technology. As we look ahead, space-based robotics and engineering programs could become a cornerstone of space education, preparing the next generation of innovators to tackle the challenges of space exploration. By combining technical expertise with creativity and ethical awareness, these programs could help humanity build a sustainable and thriving presence beyond Earth. And as we continue to explore the possibilities of space-based education, the next frontier we'll dive into is the expansion of astronomy and astrophysics programs in space, offering students unparalleled opportunities to study the universe. Now, turning our gaze to the stars, let's explore how space-based astronomy and astrophysics programs could unlock new frontiers in our understanding of the universe. Imagine a future where students aren't just reading about distant galaxies or black holes in textbooks, but are actively observing and analyzing them from space-based observatories. These programs would offer students a front-row seat to the cosmos, providing access to data and experiences that are simply impossible to replicate on Earth. One of the most exciting possibilities is the use of space telescopes and observatories designed specifically for educational purposes. Unlike ground-based telescopes, which are limited by Earth's atmosphere, space-based instruments can capture clearer and more detailed images of celestial objects. Students could use these tools to study everything from the birth of stars to the behavior of dark matter, gaining insights that could reshape our understanding of the universe. This hands-on approach would not only deepen their knowledge but also inspire a new generation of astronomers and astrophysicists. Another key aspect of these programs could be the study of cosmic phenomena in real time. For example, students might observe supernova, gamma-ray bursts, or the formation of planetary systems as they happen. This real-time data could be used to conduct groundbreaking research, allowing students to contribute to scientific discoveries while still in school. Imagine the thrill of being part of a team that identifies a new exoplanet or uncovers the secrets of a distant galaxy. Space-based astronomy programs could also focus on interdisciplinary learning, combining astrophysics with fields like engineering, computer science, and even art. Students might learn how to design and build instruments for space telescopes, develop algorithms to analyze vast amounts of astronomical data, or create visualizations that bring the wonders of the universe to life. This multidisciplinary approach would prepare students for a wide range of careers, from space exploration today to science and beyond. Collaboration with international space agencies and research institutions could further enhance these programs. Students might participate in global projects such as mapping the universe or studying the effects of cosmic radiation. These collaborations would not only provide valuable experience but also foster a sense of global community as students work together to solve some of the biggest mysteries of the cosmos. Ethical considerations would also play a role in space-based astronomy and astrophysics education. Students might discuss questions like, how do we balance the pursuit of knowledge with the need to protect celestial environments? What are the implications of discovering extraterrestrial life? These conversations would encourage students to think critically about the broader impact of their work and the responsibilities that come with exploring the universe. As we look to the future, space-based astronomy and astrophysics programs could transform how we study the cosmos, offering students unparalleled opportunities to explore the unknown. By combining cutting-edge technology with hands-on learning and ethical reflection, these programs could inspire a new era of discovery and innovation. And as we continue to push the boundaries of space-based education, the next frontier we'll explore is the potential for space-based energy studies, focusing on renewable energy sources and the possibilities of harnessing solar power in space. Now, shifting our focus to the vast potential of space-based energy studies, let's consider how education in this field could revolutionize the way we think about energy production and sustainability. Imagine a future where students are not just learning about renewable energy on Earth, but are actively exploring how to harness the limitless power of the sun from space. Space-based energy studies could open up entirely new avenues for innovation, offering solutions to some of the most pressing energy challenges we face today. One of the most promising areas of study would be the development of space-based solar power systems. Unlike solar panels on Earth, which are limited by weather, nighttime, and atmospheric interference, solar panels in space could capture sunlight continuously and at maximum efficiency. Students could learn how to design and deploy these systems, studying the engineering challenges of transmitting energy back to Earth and the potential environmental benefits of reducing our reliance on fossil fuels. This hands-on experience would not only deepen their understanding of renewable energy, but also inspire them to think creatively about solving global energy crises. Another exciting aspect of space-based energy studies could be the exploration of alternative energy sources beyond solar power. For instance, students might investigate the potential of harnessing energy from cosmic phenomena, such as the magnetic fields of planets or the radiation emitted by stars. These studies could lead to groundbreaking discoveries, offering new ways to generate clean, sustainable energy for future generations. By engaging in these cutting-edge projects, students would gain valuable skills in research, innovation, and problem-solving, preparing them for careers in the rapidly evolving energy sector. Collaboration with space agencies and private companies could further enhance these educational programs. Students might participate in real-world projects, such as designing energy-efficient habitats for space stations or developing technologies for energy storage and transmission in space. These collaborations would provide students with practical experience and expose them to the challenges and opportunities of working in the space industry. Additionally, international partnerships could foster a sense of global cooperation, as students from different countries work together to address shared energy challenges. Ethical considerations would also play a crucial role in space-based energy studies. Students might explore questions like, how do we ensure that space-based energy systems are accessible to all nations? What are the potential environmental impacts of deploying large-scale energy infrastructure in space? These discussions would encourage students to think critically about the social and ethical implications of their work, fostering a sense of responsibility and global citizenship. As we look to the future, space-based energy studies could transform how we approach energy production and sustainability, offering students the tools and knowledge to tackle some of the most pressing challenges of our time. By combining cutting-edge technology with hands-on learning and ethical reflection, these programs could inspire a new generation of innovators and problem-solvers. And as we continue to explore the possibilities of space-based education, the next frontier we'll delve into is the role of philosophy and ethics in shaping our understanding of space exploration and its impact on humanity. Now, as we venture into the realm of space-based philosophy and ethics, we uncover a fascinating dimension of education that goes beyond science and technology. Imagine a future where students in space are not only learning how to explore the cosmos, but also grappling with the profound moral questions that come with it. Space-based philosophy and ethics programs would challenge students to think deeply about the responsibilities we hold as a species venturing beyond Earth, and how our actions in space could shape the future of humanity. One of the central themes in this field would be the ethical implications of space colonization. Students might explore questions like, who has the right to claim celestial bodies or resources in space? How do we ensure that space exploration benefits all of humanity, not just a select few? These discussions would encourage students to consider the principles of fairness, equity, and justice on a cosmic scale. By engaging with these ideas, they would develop a nuanced understanding of the moral challenges that come with expanding our presence beyond Earth. Another critical area of study would be the impact of space exploration on Earth's ecosystems and societies. Students might examine the ethical dilemmas of diverting resources to space missions while pressing issues like climate change and poverty persist on our home planet. They could also explore the potential consequences of introducing Earth-based organisms to other planets or moons, and the ethical responsibilities of preserving extraterrestrial environments. These conversations would foster a sense of global stewardship, encouraging students to think holistically about the interconnectedness of Earth and space. Space-based philosophy programs could also delve into the existential questions that arise from our exploration of the universe. What does it mean to be human in the vastness of space? How do we define life, intelligence, and consciousness when encountering alien worlds? These inquiries would push students to reflect on humanity's place in the cosmos and the philosophical foundations of our quest for knowledge. By engaging with these profound questions, they would gain a deeper appreciation for the philosophical dimensions of space exploration. Collaboration with ethicists, philosophers, and scientists from around the world would enrich these programs, offering students diverse perspectives on the moral challenges of space exploration. They might participate in debates, simulations, and thought experiments that explore hypothetical scenarios, such as establishing colonies on Mars or encountering extraterrestrial life. These activities would not only sharpen their critical thinking skills, but also prepare them to navigate the complex ethical landscapes of the future. As we look ahead, space-based philosophy and ethics programs could play a vital role in shaping the values and principles that guide humanity's journey into space. By equipping students with the tools to think critically about the moral implications of their actions, these programs would ensure that space exploration is conducted with integrity, responsibility, and a deep respect for the universe we seek to understand. And as we continue to explore the possibilities of space-based education, the next frontier we'll turn to is the development of sports and physical education programs designed for life in microgravity environments. Now, shifting our focus to the physical side of space-based education, let's explore how sports and physical education could evolve in microgravity environments. In space, where the absence of gravity changes the way our bodies function, maintaining physical health becomes a unique challenge. Space-based sports and physical education programs would not only help astronauts and students stay fit, but also redefine what it means to play and exercise beyond Earth. One of the most exciting possibilities is the creation of new sports specifically designed for microgravity. Imagine a game where players float freely, using walls and ceilings as part of the playing field. These sports would require a blend of agility, strategy, and teamwork, offering a thrilling way to stay active while adapting to the unique conditions of space. Such activities could also foster camaraderie and teamwork among students, making physical education both fun and functional. Traditional exercises like running or weightlifting wouldn't work in space, so physical education programs would need to innovate. Resistance training using elastic bands, cycling on specially designed stationary bikes, and even virtual reality workouts could become staples of space-based fitness routines. These programs would focus on counteracting the effects of microgravity, such as muscle atrophy and bone density loss, ensuring that students remain healthy and strong during their time in space. Beyond physical health, these programs could also address mental well-being. Exercise is known to reduce stress and improve mood, and in the isolated environment of space, this becomes even more important. Sports and physical activities could provide a much-needed outlet for relaxation and social interaction, helping students cope with the challenges of living far from Earth. Collaboration with experts in kinesiology, sports science, and space medicine would be essential to design effective programs. Students might participate in research studies to test new exercise equipment or develop innovative fitness routines tailored to microgravity. These experiences would not only keep them physically fit but also deepen their understanding of human physiology and the effects of space on the body. As we look to the future, space-based sports and physical education could become a cornerstone of life beyond Earth. By combining innovation with tradition, these programs would ensure that students and astronauts alike stay healthy, happy, and ready to tackle the challenges of space exploration. And as we continue to push the boundaries of what's possible, the next frontier we'll explore is the fascinating intersection of space and sound, where music and sound studies take on a whole new dimension. Now, let's tune into a fascinating aspect of space-based education that harmonizes science and creativity: music and sound studies in space. In the vacuum of space, where sound as we know it doesn't travel, the study of music and sound takes on an entirely new dimension. This unique environment opens up opportunities for students to explore how sound behaves or doesn't behave in microgravity, and how this can inspire innovative forms of musical expression. One of the most intriguing aspects of space-based music studies is the absence of traditional sound waves. On Earth, sound travels through air, but in space, there's no medium for it to propagate. This means that instruments and voices wouldn't produce audible sound in the same way. However, this limitation could spark creativity, leading to the development of entirely new instruments and sound technologies. Imagine devices that use vibrations or electromagnetic waves to create music, allowing students to compose and perform in ways that are impossible on Earth. Space-based music programs could also delve into the psychological and emotional impact of sound in isolated environments. Music has long been a source of comfort and inspiration, and in the vast, silent expanse of space, it could play a crucial role in maintaining mental well-being. Students might study how different types of music affect mood and focus, or even collaborate with psychologists to design soundscapes that help astronauts and space residents cope with the challenges of living far from home. Another exciting possibility is the exploration of how sound interacts with other elements in space. For example, students could experiment with how vibrations travel through spacecraft materials or how sound waves behave in pressurized environments. These studies could lead to practical applications, such as improving communication systems or designing better acoustic environments for living and working in space. Beyond the technical aspects, space-based music studies could also inspire new artistic movements. The unique conditions of space might give rise to avant-garde compositions that challenge our understanding of music. Students could collaborate with artists and musicians from around the world, blending cultural influences with the novelty of space to create groundbreaking works of art. As we look to the future, space-based music and sound studies could become a vibrant field that bridges science and creativity. By exploring the boundaries of sound and music in microgravity, students would not only deepen their understanding of physics and acoustics, but also contribute to a richer, more diverse cultural landscape in space. And as we continue to push the boundaries of human exploration, The next frontier we'll explore is the intersection of space and style, where fashion and design take on a whole new meaning. Now let's shift our gaze to a realm where style meets the stars, space-based fashion and design. In the unique environment of space where functionality and aesthetics must coexist, the concept of clothing takes on a whole new dimension. Imagine designing garments that not only look stunning but also address the practical challenges of living and working in microgravity. This is where space-based fashion programs come into play, blending creativity with cutting-edge technology to redefine what it means to dress for the cosmos. One of the most exciting aspects of space fashion is the need for adaptability. Traditional clothing designed for Earth simply doesn't cut it in space. In microgravity, fabrics behave differently, and the absence of gravity means that loose-fitting garments can float awkwardly, potentially interfering with movement or equipment. Space-based fashion programs would focus on creating clothing that is both functional and stylish, using materials that are lightweight, durable, and resistant to the harsh conditions of space. Think sleek, form-fitting designs that minimize bulk while maximizing comfort and mobility. But functionality is just the beginning. Space fashion also opens up a world of creative possibilities. Designers could experiment with innovative materials, such as smart fabrics that regulate temperature or change color in response to environmental conditions. Imagine a spacesuit that adapts its insulation based on the temperature outside, or a jacket that glows softly in the darkness of space. These advancements wouldn't just be practical, they'd also allow for self-expression, enabling astronauts and space residents to showcase their individuality even in the most extreme environments. Another fascinating area of exploration is the psychological impact of fashion in space. Clothing plays a significant role in how we perceive ourselves and others, and this remains true even in the isolation of space. Space-based fashion programs could study how different styles and colors affect mood and morale, helping to design wardrobes that boost mental well-being. For instance, vibrant colors and bold patterns might help combat the monotony of a space station's interior, while softer tones could create a calming atmosphere for relaxation. Collaboration will be key in this field. Space-based fashion programs could bring together designers, engineers, and scientists to create clothing that meets both aesthetic and technical requirements. Students might work on projects like designing spacesuits that are not only functional but also visually striking, or creating everyday wear that combines comfort with a touch of cosmic flair. These collaborations could lead to groundbreaking innovations that benefit not just space exploration but also fashion on Earth, inspiring new trends and technologies. As we look to the future, space-based fashion and design could become a thriving field that pushes the boundaries of creativity and functionality. By reimagining what clothing can be in the context of space, students and designers alike would contribute to a future where style and practicality go hand in hand, even among the stars. And as we continue to explore the possibilities of space-based education, our next stop takes us to the world of storytelling, where the cosmos becomes a canvas for imagination and expression. Now, let's turn our attention to a realm where imagination knows no bounds: space-based literature and storytelling. In the vast expanse of the cosmos, where every star and planet holds a story waiting to be told, the art of storytelling takes on a whole new dimension. Imagine students floating in a space station, gazing out at the Earth or the infinite stars, drawing inspiration from the beauty and mystery of the universe to craft tales that transcend time and space. This is the future of space-based literature programs, where the cosmos becomes a canvas for creativity and expression. One of the most compelling aspects of space-based storytelling is the unique perspective it offers. Living and working in space provides an unparalleled vantage point, allowing students to see the Earth from afar and experience the wonders of the universe firsthand. These experiences could inspire stories that explore themes of exploration, discovery, and the human condition in ways that are impossible to replicate on Earth. Picture a student writing a novel about the first colony on Mars, or a poet capturing the ethereal beauty of a solar eclipse viewed from orbit. The possibilities are as limitless as the universe itself. But space-based literature isn't just about inspiration, it's also about connection. In the isolation of space, storytelling becomes a powerful tool for building community and fostering empathy. Students could share their stories with one another, creating a shared narrative that reflects their collective experiences and dreams. These stories could be transmitted back to Earth, allowing people on the ground to glimpse life in space through the eyes of those who live it. This exchange of ideas and perspectives could bridge the gap between Earth and space, fostering a deeper understanding of our place in the cosmos. Another exciting possibility is the integration of technology into storytelling. Virtual reality and augmented reality could allow students to create immersive narratives that transport readers to distant planets or ancient galaxies. Imagine a story that unfolds not just on the page, but in a fully interactive virtual environment, where readers can explore alien landscapes or interact with characters in real time. These innovations would push the boundaries of what storytelling can be, blending traditional literary techniques with cutting-edge technology to create entirely new forms of expression. Space-based literature programs could also explore the cultural and historical dimensions of storytelling. Students might study the myths and legends of different cultures, examining how humanity has always looked to the stars for inspiration. They could then draw on these traditions to create stories that reflect both the past and the future, weaving together ancient wisdom and modern science. This fusion of old and new could result in literature that is both timeless and forward-thinking, offering insights into the human experience that resonate across generations. As we look to the future, space-based literature and storytelling could become a vibrant field that enriches our understanding of the universe and ourselves. By encouraging students to write and share their cosmic experiences, these programs would not only inspire creativity, but also foster a sense of connection and wonder. And as we continue to explore the possibilities of space-based education, our next stop takes us to the social sciences, where we'll examine how space exploration shapes society and culture. Now, let's shift our focus to a fascinating intersection of space and society, space-based social sciences. As humanity ventures further into the cosmos, the social sciences will play a crucial role in understanding how space exploration and colonization shape our societies, cultures, and even our identities. Imagine students aboard a space station, not just studying the stars, but also examining the profound ways in which living and working in space transforms human behavior, relationships, and societal structures. One of the most intriguing aspects of space-based social sciences is the study of how microgravity and isolation impact human psychology and group dynamics. Living in space presents unique challenges, from the physical effects of zero gravity to the emotional strain of being far from Earth. Social scientists could explore how these conditions influence teamwork, decision-making, and conflict resolution. For instance, how do astronauts from different cultural backgrounds collaborate effectively in such a high-stakes environment? These insights could lead to better strategies for fostering cooperation and resilience, not just in space but also in challenging environments on Earth. Another key area of study would be the societal implications of space colonization. As we establish colonies on the Moon, Mars, or even beyond, we'll need to address questions about governance, resource allocation, and cultural identity. How do we create fair and sustainable societies in space? What legal frameworks will govern these new settlements? Space-based social sciences could delve into these issues, drawing on disciplines like sociology, political science, and anthropology to develop models for thriving extraterrestrial communities. Students might even participate in simulations, designing and testing social systems for future colonies. space exploration also offers a unique lens through which to examine Earth's own social challenges. From space, national borders disappear, and the planet appears as a single, interconnected system. This perspective could inspire new ways of thinking about global issues like climate change, inequality, and conflict resolution. Social scientists in space could study how this overview effect, the profound shift in awareness reported by astronauts, impacts attitudes toward environmental stewardship and international cooperation. These findings could inform efforts to address pressing global challenges, fostering a sense of shared responsibility for our planet. Cultural exchange and preservation will also be a vital focus of space-based social sciences. As humans from diverse backgrounds come together in space, they'll bring their languages, traditions, and worldviews. Social scientists could explore how these cultures blend and evolve in the unique environment of space, creating new forms of expression and identity. At the same time, they could work to preserve cultural heritage, ensuring that the richness of Earth's traditions is carried forward into the cosmos. This dual focus on innovation and preservation could lead to a vibrant, inclusive space culture that celebrates diversity while fostering unity. As we look to the future, space-based social sciences could provide invaluable insights into the human experience, helping us navigate the challenges and opportunities of life beyond Earth. By studying the societal impacts of space exploration, we can build a foundation for a future where humanity thrives not just on Earth but among the stars. And as we continue our journey through the possibilities of space-based education, our next stop takes us to the realm of interdisciplinary studies, where we'll explore how combining multiple fields of knowledge can unlock groundbreaking discoveries in space exploration. Now, let's turn our attention to a concept that could redefine the future of space-based education: interdisciplinary studies. Imagine a learning environment where students don't just focus on one subject, but combine knowledge from multiple fields to tackle the complex challenges of space exploration. This approach could unlock groundbreaking discoveries and innovations, pushing the boundaries of what we thought was possible. Interdisciplinary programs in space would bring together experts and students from diverse fields: science, engineering, art, social sciences, and more, to collaborate on solving problems that no single discipline could address alone. For example, designing a sustainable habitat on Mars would require not just engineers and architects, but also biologists to study life support systems, psychologists to ensure mental well-being, and artists to create spaces that inspire and uplift. By working together, these teams could develop solutions that are not only functional but also holistic, addressing every aspect of life in space. One of the most exciting possibilities of interdisciplinary studies is the potential for unexpected breakthroughs. When experts from different fields share their perspectives, they often spark new ideas that wouldn't have emerged otherwise. Think about how combining robotics and biology could lead to advanced prosthetics for astronauts, or how merging environmental science with engineering could result in more efficient ways to recycle resources in space. These collaborations could lead to innovations that benefit not just space exploration, but also life on Earth. Another key advantage of interdisciplinary programs is their ability to prepare students for the realities of space exploration, where challenges rarely fit neatly into one category. For instance, managing a space colony would require understanding not just the technical aspects of life support systems, but also the social dynamics of the community living there. Students in interdisciplinary programs would learn to think critically, adapt to new situations, and approach problems from multiple angles, skills that are essential for thriving in the unpredictable environment of space. Moreover, interdisciplinary studies could foster a culture of creativity and curiosity, encouraging students to explore connections between seemingly unrelated fields. Imagine a program where astrophysicists collaborate with musicians to study the sounds of space, or where historians work with engineers to preserve the legacy of space exploration. These unique partnerships could inspire new ways of thinking and open up entirely new areas of research. As we look to the future, interdisciplinary studies could become the cornerstone of space-based education, equipping students with the tools they need to tackle the grand challenges of space exploration. By breaking down the barriers between disciplines, we can create a learning environment that is as vast and interconnected as the cosmos itself. And as we continue to explore the possibilities of space-based education, our next stop takes us to the role of collaboration in driving these interdisciplinary efforts forward, where we'll see how teamwork across fields can lead to even greater achievements. Now, let's take a closer look at how collaboration across disciplines could shape the future of space-based education. When we bring together minds from different fields, the potential for innovation becomes limitless. Picture a team of scientists, engineers, artists, and social scientists working side by side on a space station, each contributing their unique expertise to solve a shared challenge. This kind of collaboration doesn't just combine knowledge, it creates something entirely new, sparking ideas that might never have emerged in isolation. One of the most powerful aspects of interdisciplinary collaboration is its ability to tackle problems from multiple angles. Take, for instance, the challenge of designing a sustainable habitat on the Moon. Engineers might focus on the structural integrity of the habitat, while biologists work on creating closed-loop life support systems. At the same time, psychologists could study how to maintain the mental health of the crew, and artists might design spaces that promote creativity and reduce stress. By integrating these diverse perspectives, the team can develop solutions that are not only functional but also holistic, addressing every aspect of life in space. Collaboration also encourages a culture of continuous learning and adaptability. In a space-based education setting, students and researchers would constantly be exposed to new ideas and approaches, pushing them to think outside their comfort zones. For example, a robotics engineer might learn about environmental science to better understand how to design systems that minimize waste, while a historian could gain insights into engineering to help preserve the legacy of space exploration. This cross-pollination of knowledge fosters a mindset of curiosity and innovation, essential for tackling the unknown challenges of space. Moreover, interdisciplinary collaboration has the potential to accelerate the pace of discovery. When experts from different fields come together, they often uncover connections that others might overlook. Imagine a team of astrophysicists and musicians collaborating to study the sounds of space, or environmental scientists working with engineers to develop new ways of harnessing solar energy. These partnerships could lead to breakthroughs that not only advance space exploration, but also have practical applications here on Earth. Another key benefit of collaboration is its ability to prepare students for the realities of working in space. Space exploration is inherently unpredictable, and challenges rarely fit neatly into one discipline. By working in interdisciplinary teams, students learn to communicate effectively, think critically, and adapt to new situations, skills that are crucial for success in the dynamic environment of space. They also gain a deeper appreciation for the interconnectedness of knowledge, understanding that solving complex problems often requires a blend of expertise. As we look to the future, collaboration will undoubtedly play a central role in space-based education. By breaking down the barriers between disciplines, we can create a learning environment that mirrors the complexity and interconnectedness of the cosmos itself. And as we continue to explore the possibilities of space-based education, our next stop takes us to the challenges and opportunities that lie ahead, where we'll examine how to overcome obstacles and unlock the full potential of learning beyond Earth. Now, as we turn our attention to the challenges and opportunities of space-based education, it's important to recognize that this groundbreaking field is not without its hurdles. One of the most significant challenges lies in funding. Establishing and maintaining educational programs in space requires substantial financial investment. From building and launching space stations to developing specialized equipment and training educators, the costs can be astronomical. Governments, private companies, and international organizations will need to collaborate closely to secure the necessary resources, ensuring that space-based education becomes a sustainable reality rather than a fleeting dream. Accessibility is another major challenge. While the idea of learning in space is thrilling, it raises questions about who gets to participate. Currently, space travel and research opportunities are limited to a select few, often due to financial or geographical barriers. To truly democratize space-based education, we'll need to develop innovative solutions such as virtual reality platforms that allow students from all over the world to experience space-based learning without leaving Earth. Additionally, scholarships and partnerships with educational institutions could help bridge the gap, making these programs accessible to a more diverse group of learners. Despite these challenges, the opportunities presented by space-based education are immense. For one, it has the potential to inspire a new generation of scientists, engineers, and explorers. Imagine a young student conducting experiments in microgravity or collaborating with peers from different countries on a space station project. These experiences could ignite a lifelong passion for STEM fields, driving innovation and discovery for decades to come. Moreover, space-based education could foster a deeper understanding of our planet and the universe, encouraging students to think critically about global challenges like climate change and resource scarcity. Another exciting opportunity lies in the potential for international collaboration. Space-based education could bring together students and researchers from around the world, creating a truly global learning community. This cultural exchange would not only enrich the educational experience, but also promote peace and cooperation on a planetary scale. By working together to solve the challenges of space exploration, we can build a future where humanity is united by a shared sense of curiosity and purpose. Finally, space-based education could serve as a testing ground for new technologies and teaching methods. The unique environment of space offers a chance to experiment with innovative approaches to learning, from AI-powered tutors to immersive virtual reality labs. These advancements could eventually be adapted for use on Earth, revolutionizing education as we know it. For example, the lessons learned about maintaining mental health and fostering creativity in space could inform how we design classrooms and support students in traditional settings. As we navigate the challenges and embrace the opportunities of space-based education, one thing is clear: the potential for growth and discovery is limitless. By addressing the obstacles head-on and leveraging the unique advantages of space, we can create a future where learning knows no bounds. And as we continue to explore this exciting frontier, our next step takes us to the ethical considerations of space-based education, where we'll examine the moral implications of this transformative field. Now, as we delve into the ethical implications of space-based education, it's crucial to consider how this transformative field will shape not only the future of learning, but also the values we uphold as a global society. One of the most pressing ethical questions revolves around equity and access. Who gets to benefit from space-based education, and how can we ensure that these opportunities are distributed fairly? If space-based programs remain exclusive to a privileged few, they risk exacerbating existing inequalities, leaving behind students from underfunded schools or developing nations. To address this, we must prioritize creating inclusive systems that provide equal access to space-based learning, whether through virtual platforms, scholarships, or international partnerships. Another ethical concern is the potential impact on Earth-based education systems. As resources and attention shift towards space-based initiatives, there's a risk that traditional education systems could be neglected. This raises questions about how to balance investment in cutting-edge space programs with the need to improve and sustain education on Earth. After all, millions of students still lack access to basic resources like textbooks, qualified teachers, and safe learning environments. Space-based education should complement, not replace, efforts to address these challenges, ensuring that progress in one area doesn't come at the expense of another. The ethical considerations also extend to the environmental impact of space-based education. Launching and maintaining space stations and satellites requires significant energy and resources, which could contribute to environmental degradation if not managed responsibly. As we expand into space, we must adopt sustainable practices that minimize harm to our planet. This includes developing eco-friendly technologies and ensuring that space-based education programs actively promote environmental stewardship, teaching students to care for both Earth and the cosmos. Additionally, there's the question of cultural representation and respect. Space-based education will bring together students and educators from diverse backgrounds, creating opportunities for cultural exchange, but also potential for misunderstanding or conflict. It's essential to design curricula that celebrate diversity and foster mutual respect, ensuring that no single culture dominates the narrative. By embracing a global perspective, space-based education can become a powerful tool for promoting unity and understanding among people of different nations and traditions. Finally, we must consider the long-term implications of space-based education on humanity's relationship with space itself. As we establish more permanent educational and research facilities beyond Earth, we'll need to grapple with questions about our responsibilities as explorers and inhabitants of the cosmos. How do we ensure that our activities in space are conducted ethically, respecting the integrity of celestial environments and avoiding exploitation? These are complex issues that will require ongoing dialogue and collaboration among scientists, educators, policymakers, and the public. As we navigate these ethical challenges, it's clear that space-based education holds immense potential to inspire and unite humanity. But to fully realize this potential, we must approach it with a commitment to fairness, sustainability, and respect for all. By addressing these ethical considerations head-on, we can create a future where space-based education not only advances knowledge but also reflects the best of our shared values. And as we continue to explore this frontier, our next step takes us to the conclusion of our journey, where we'll reflect on the transformative possibilities of space-based education and research. As we bring our exploration of the future of space-based education and research to a close, let's take a moment to reflect on the incredible possibilities we've uncovered. From zero-gravity classrooms and virtual reality space labs to international space universities and AI-powered tutors, the potential for innovation is boundless. These predictions paint a picture of a future where learning transcends the limits of Earth, offering students and researchers unparalleled opportunities to explore, discover, and create. Space-based education isn't just about advancing science and technology. It's about reimagining how we learn, collaborate, and grow as a global community. Imagine a world where students from every corner of the planet can conduct experiments in microgravity, study the stars from orbit, or design solutions for life on Mars. Picture a future where space-based research stations become hubs of discovery, pushing the boundaries of human knowledge and addressing some of the most pressing challenges we face. This isn't just science fiction, it's a vision that's within our reach, fueled by the rapid advancements in technology and the growing interest in space exploration. But realizing this future requires more than just innovation, it requires action. Each of us has a role to play in shaping the future of space-based education and research. Whether you're a student, educator, scientist, or simply someone passionate about the cosmos, there are countless ways to contribute. Advocate for inclusive and equitable access to space-based learning. Support initiatives that promote sustainability and environmental stewardship in space exploration. Share your ideas, your curiosity, and your enthusiasm for the possibilities that lie beyond our planet. The journey to space-based education is just beginning, and the road ahead is filled with challenges and opportunities. But if history has taught us anything, it's that humanity thrives when we dream big and work together. So let's dream of a future where the stars are not just a destination but a classroom, a laboratory, and a source of endless inspiration. Together, we can turn these predictions into reality and create a brighter, more connected future for generations to come. If you're as excited about this vision as we are, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an update on the latest in futuristic technologies and lifestyle. And most importantly, share your thoughts in the comments below. What excites you most about the future of space-based education? Let's keep the conversation going and build this incredible future together. Thank you for joining us on this journey, and we'll see you in the next video.